Hello everyone, Aaron here and welcome back to Leetcode. Today we are doing the add one row to tree problem. Jumping right in, given the root of a binary tree and two integers, val and depth, add a row of nodes with value val at the given depth. Note that the root node is at depth 1. Given the integer depth for each not null tree node current at depth minus 1, create two tree nodes with the same val as car's left subtree root and right subtree root. Holy hell, that's a confusing sentence. Carrot's original left subtree should be the left subtree of the new left subtree root. Carrot's original right subtree should be the right subtree of the new right subtree root. If depth is equal to 1, that means there is no depth minus 1 at all. Then create a tree node with value val as the new root of the whole original tree, and the original tree is the new root left subtree. Okay. So in this first case, we're adding them at depth 2, which means this layer here needs to bump down. So above each one, we insert a 1. That makes sense. Here we're inserting at depth 3, so 1, 2. These two need to get bumped down. Okay, that makes sense too. So what's this business about not null? So okay, I'm a little unsure on what the exact behavior is meant to be if, say, this subtree didn't exist. Do we still add this 1? Maybe? I don't know. Let's go in here. Def add row helper self node val depth. If depth is equal to 2, I guess. So the layer I want to affect is the layer immediately below where I am. So what I want to do is old left is node dot left, old right is node dot right. In fact, hang on. If node is none, return. If depth is less than 2, return. And then, so now I've got the old left and the old right. What I want to do is node dot left is tree node val left is old left none, node dot right is tree node val none old right, else add row helper self node dot left val depth minus 1, add row helper self node dot right val depth minus 1. If depth equals 1, do something clever. Else at self, oh, that's what I got marked up down here. Sorry, switching between languages is always fun, as is switching between editors, which have different hotkeys. So this part here basically says dig down until I'm just one above where I'm meant to be inserting these things. So here, dig down until I reach the 4, and then add this extra layer in. Basically stop digging if you dug too far. And to kick it off, helper is root val depth. So the one trick is that if we're at the top already, if the depth is 1, there was a special case here. If the depth is 1, that means there is no depth minus 1. Then create a tree node with value val as the new root of the whole original tree, and the original tree is the new root left subtree. So what I want to do is I want to hang on, am I mutating this tree? It's unclear. Val root none. Maybe I need to be actually producing a new tree. Node, if depth is less than 2, return node. So then what I want to do is make a new left and a new right, and then I want to return a tree node which is node.val new left new right. Actually, if I'm producing a completely new tree, I don't actually want to do it this way at all. Yeah, this is all just a special case. No, it's because I need to know whether I'm turning left or right. I think this is fine. New left, new right, return tree node, node.val, new left, new right. Okay. So this is actually slightly confusing. If I didn't have to do this deciding which way I'm adding a child, it would be fine. Because I do need to do that decision, it's a surprisingly complicated puzzle. So this first one works, but it's too fast anyway. I also want to do a case where, what's the format for this? It's reading across. I want to do 4, 2, null, 3, 1, but I don't want to insert it at depth 3. I want to insert it at depth 2. So let's see what happens. Yeah, okay, that. Apparently I got the behavior right, whatever the behavior was. And the behavior I've said here is that if I'm inserting something immediately below the 4, not immediately below the 2, then I want to insert a 1 on each side. I think that works. Gosh, this is not the nicest problem, actually. Let's submit it, see what happens. Excellent. Apparently that was the expected solution. This is quite a functional problem. Python isn't really the greatest language for this. You'd really want to do this in something like StandML or Camel or Haskell, or a language that really makes these kind of functional updates easy, because you can see here we've got a fair bit of cruft involved doing this, trying to build a new tree. It's not natural for Python. But it works, so I'm happy. We weren't very fast at all, but as we learned a couple of days ago, those numbers mean basically nothing. Anyway, I think that's good. I do hope you enjoyed the content. Do remember to like, comment, subscribe, all of that good stuff. Do let the algorithm know that I'm writing good algorithms, and you should definitely be watching all my content. So that's it from me today, and I will see you next time. Bye.